Hi, good day to you and welcome to my channel where I tutor you in science for free. The topic in this video will be the periodic table. So this is a periodic table. You can see that there's a lot of elements packed over here. So why is it in this fashion? You can see that in the general shape it's like a long rectangle. The columns are called the groups. And why are they packed and arranged in this group form? Because the outermost shell shows the number of electrons they have in that particular group. So all those in group 1 have 1 electron in that outer shell, so on and so forth. And the rows depict the number of shell that they have. So the first row, the first period will be 1 shell, second row 2 shell, so on and so forth. There's a common confusion between group and period. So the short word group will correspond to the short dimension of the rectangle. The long word period having 6 letters versus group of 5 letters will correspond to the long side of the periodic table. This is an odd shape. It is classified like that because of several reasons. These on the right side will be the non-metals, and all of these on the left side and the middle will be the metals. Those in the middle will be called the metalloids, where they show some properties of metals and non-metals. And this middle block here will be known as the transition metals, where we will learn more about them later. So across the period, from left to right, there is a change of characteristics of these elements from metallic character to non-metallic character. So the electronic structure will correspond accordingly to its group and also its period. So let's take a look at, for example, carbon, group 4, period 2. It has 2 shells and 4 outermost electrons. So this is how it would look like. And recall from earlier topics, the first shell, the full shell for the first shell will be 2, and the subsequent ones will be 8. And it's just sufficient for your level to learn up to proton number 20, calcium. A full shell will look like that in the argon, period 3, group 0, which also means that it has a full electron configuration. Therefore, it is 2, 8, and 8. And one more important thing to note is that the elements with the same number of valence electrons will show very similar chemical properties and participate in similar chemical reactions. Placing them like that in a column will allow the reader to easily anticipate the kind of characteristics it has. So for group 1, called the alkali metals, it has these properties: soft, can be cut easily, low melting, boiling points, low density, they float on water, and these are commonly asked because they are, although called metals, but they do not have the common metallic properties like being hard and heavy, dense, high melting points. They are complete opposite. And going down the group, melting points and boiling points decrease, densities generally decrease. So using this knowledge, you can predict properties of the alkali metals if need be, because they follow a trend. So we move on to the chemical properties of alkali metals, the group 1. Going down the group, it gets more and more reactive. Remember that F, francium, also means fast. I like to think of it this way. It's easy to understand. So group 1 metals react with cold water to form alkali with hydrogen. And because they are all generally pretty reactive, they are good reducing agents. They like to contribute the electron to the other party, causing them to drop in an oxidation state. So they reduce others in the process of getting themselves oxidized. And because they are in group 1, they have only 1 electron in their valence shell. It's easier for them to donate it away. Therefore, they will form ionic compounds. Okay, next will be the group 7. Special name known for them will be the halogens, because they exist as discrete diatomic covalent molecules. Discrete means separate and individual. They have low melting points, low boiling points, because there's low amount of intermolecular forces between them. Not a lot of energy is required to overcome these forces. They have colors as well. So going down the group, the melting and boiling points increase. The color gets darker and darker. The state goes from gas to liquid to solid. And because of trends like this, we are able to also predict and anticipate the properties of the next one. These are reactive non-metals because Each of them has already 7 electrons on the valence shell. It just needs to receive 1 more electron to form a ion. These elements in the group 7 also follow a reactivity order. So similar to group 1, the element F, fluorine, is the one that reacts the fastest. So I usually tell my students F to F, these are the ones that reacts the fastest, francium and fluorine. Remember F for fast. So going down the group, it gets less and less reactive. And because of this reactivity order, they participate in displacement reaction. Remember, displacement reaction is your snatch boyfriend or snatch girlfriend reaction. So what does it mean? So one of them already has a partner, it will go in to snatch the partner. Any element that is more reactive will be able to displace the one that is less reactive. And because of them having 7 valence electrons, it very readily accepts 1 more. Therefore, they are powerful oxidizing agents. They readily accept electrons from others in the process, getting itself reduced. Next, we talk about group 0 elements, noble gases. We don't usually call them group 8 because the shells get bigger and bigger in going down the group. The valence electrons actually get more and more, but collectively, it is commonly agreed that the number 0 is used to represent having a full shell. This is pretty much the easiest one because they have full shell, they will be monoatomic, they don't partner with anybody. Colors, gases, low melting boiling points, insoluble, unreactive. They are used for a wide array of applications because they are unreactive. Lastly, I'd just like to briefly touch on transition elements, the transition metals. Over here is the big block in the middle. Basically, you just need to know a little bit of their characteristics, but you don't have to go and particularly commit to memory what kind of color, what kind of oxidation states they will have. Basically, they will have high melting points, high boiling points, high density. Variable oxidation states means they are able to have more than 1 or 2 or 3 common oxidation states, and they also form colored compounds and also usually act as catalysts. Catalysts are things that help speed up the process of reaction, taking a shorter time or lowering the energy required to input into the reaction. And pretty much that's about it. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!